You are welcome to another video of Yang-based network automation using NetConf, RESTCONF, and GNMI. From this section, we'll start to send RESTCONF requests through the Python script. We will use request library, which is the most famous Python library used to send HTTP requests. However, Python request library does not have inventory management and multi-threading capabilities of the Nornir plugin, but from the next section we will start to use again Nornir plugin to work with the RESTCONF protocol. Request library is the most famous Python library used to send HTTP requests through Python script. Here we use Python request library to get the configuration of network devices. However, we need to provide the IP address of network devices and also the credential inside the Python script because the Python request library does not have the features like inventory management. This is a sample Python code snippet to send HTTP requests through request library. In the first line, we import the request library. In the URL variable, we specify the URL of the RESTCONF protocol in the network device where we get or set the configuration. This is the most important part of the code snippet. I've already explained in the netconf protocol in the lesson 6 and lesson 7 how to get the XPath to reach each part of the configuration. The first part of the URL is always fixed, the IP address and port to connect to the network device, and then /restconf/data. But the second part of the URL is what you need to know to get or set the configuration. The second part of the URL is the XPath to reach each part of the configuration. For network devices, netconf is still the best way to find the XPath as we have discussed in lesson 6 and lesson 7. However, for more modern network solutions such as network SDN solutions, there is detailed RESTCONF documentation showing the RESTCONF URL to reach each section of the configuration. The other method that can be sometimes helpful is public postman collections. For example, here in this link, when you say Cisco DevNet Postman Collection, you will find this URL easily through the Google. This is the link on the Postman website, has public Postman collections for most Cisco devices. Cisco iOS XE is also inside the collection, and then RESTCONF, and here there are many sample REST API. Inside each of them there is also the URL which has to be used to reach that part of the configuration. You can use existing API requests as a reference or as a sample to be used also in your Python requests. Payload and headers are the other section of the Python request library to get or set the configuration of network devices. We use payload when we upload a new configuration to the network devices. In this code snippet, we are receiving the configuration. Therefore, the payload section is empty. The format of receiving or sending the configuration can be XML or JSON in RESTCONF protocol, which will be configured in the accept and content type header fields. And finally, we send the request using request library. Here, the HTTP command get is used to get the configuration, headers, and payload and authentication information will also be given in the request command to be sent to the network devices. There are also some features in the URL to filter and limit the request to more specific part of the configuration or statistics. With equal sign, we can limit the request to a more specific section. For example, a specific interface equal gigabit Ethernet 1, or a specific OSPF process ID, OSPF and the process ID 1 if there is more than one OSPF process in the router. These two lines are using the equal sign to filter the output to more specific section of the configuration. With content equal config or content equal non-config, for the open config YAN data model, we are allowed to request configuration section or a statistic section of any specific part of the network device like interfaces if you need the configuration section or a statistic section of the interface. The third and the fourth URL are using the content feature to limit the request to the configuration or to the statistic. For the Cisco Yang data model, this method does not work since in Cisco, configuration Yang data model and a statistic Yang data model are completely in different files. In Cisco, the name of the statistic Yang data model have an extra dash upper at the end in compared to the configuration Yang data model. You are also allowed to combine the capability of the equal sign and also content keyword to extract the configuration or a statistic information of a specific interface or a specific OSPF process ID. The last URL has combined the both equal and content capability to limit the output to interface gigabit Ethernet 1 statistics only. This is the script that we run in this section with more than 10 URL examples. As you can see, 15 URL examples. The structure of the request and URL is already explained. The response of the request can be displayed with printing any of response.text or response.content. Response.text shows human readable output, but response.content shows the original output in the format of XML or JSON depending on the header accept field that you use in your request. Here I've used two header. Header 1 is for the XML and header 2 is for the JSON. Also, I use here our print instead of print from the rich library just to see the nicer output. Let's run the script. For example, for URL 0 and header 2, which is JSON. And I will show also what is URL 0 and I will comment the other sections. This is the URL 0, RESTCONF data, IETF interfaces and interfaces, which shows the list of the interfaces. Once we are printing the response.text, which is human readable output, the other response.content, which is the original output format. Let's save and run the script. URL 0. Here I've written run. Again, run the script. This is the output of response.text. As you can see, completely human readable, and there is two interface, gigabit Ethernet 1 with this IP address and loopback 100 with the other IP address. But this is the output of the JSON original format, which is not readable but can be processable, as I will explain in a few minutes. But to be able to process the output and access any part of the output, we need to convert the JSON or XML output to Python dictionary format. For XML output, we use XML to dict.parse and then XML response from the XML to dict Python library to convert it to the dictionary, which can be processed by the Python. And for JSON output, we use response.json to convert it to a dictionary. Just to check, let's choose the header field once as XML and once as JSON and convert it to a dictionary format. Header 1 is the XML output, and here are comment these lines, and instead of that I will check the output, XML output, and convert it to the dictionary, and then I can print the dictionary output, which is not necessarily human readable but can be processed by Python script. Let's run the script. As you can see, this is the dictionary output of the output. Here also displayed or the dictionary and ordered dictionary. And let's check once again, but this time with the JSON output with the header 2, and then I comment the XML processing and convert the response to the dictionary, JSON response to the dictionary with response.json library, and then print the output again, and we run the script. And this is the output, and what is different in this output is in the format of dictionary and can be processed by the Python script. When the XML or JSON is converted to a dictionary, then it can be easily processed by Python script to access any field in the output. We have already discussed this topic in the course CLI-based network automation using Python Nornir and in the output of text FSM and Jenny parser, which give us the dictionary output. For example, text FSM and Jenny parser. We have already discussed how a dictionary can be processed in the Python script. In our script, we use, for example, URL 11 to receive the gigabit Ethernet 1 interface statistic from the OpenConfig interface Yang data model. But to go further and receive the specific contours of the interface gigabit Ethernet statistic, we can use here URL 11, and then here I use the output and then OpenConfig interfaces and then interface and then state and then content to receive the specific contours of the interface gigabit Ethernet 1 statistics. I've already used the for loop for key and value in the response.items to find the key and values, as I've explained already in the CLI-based network automation, and I have found these dictionary key sequences to reach the specific output, and then I can print the final result. Again, dictionary response is not defined here, and then run again. These are the contours related to gigabit Ethernet 1 interface. And to go further, for example, I can use in-octet at the end of this to see the incoming bytes to the interface. Paste, and then again run the script, and these are the statistics of the gigabit Ethernet 1 regarding the incoming packets. As I've explained, the key sequence here can be easily be extracted in the output of the URL 11 JSON output, or by looping over the output items and printing the key and value, as I have shown here in the script.